Hi everyone, in today's lesson we're going to learn about geometric sequences. By definition, if a sequence of values follows a pattern of multiplying a fixed amount, which is not zero, times each term to arrive at the following term, it's referred to as a geometric sequence. The number multiplied each time is always the same. The fixed amount that we actually multiply is called the common ratio, denoted by the letter R. So for example, for each of these four different answers here, questions, I want you to find the common ratio and then find the 10th term. So for the first one, let's look at the pattern. How do I go from 2 to 4 to 8 to 16? So it looks like we're multiplying by 2. So my common ratio here is 2. And if I want to find the 10th term, I'm just going to have to follow the pattern. So I have 4 terms already. Times 2 is 32. That would be my 6th term. Times 2 is 64. That's my 7th. Times 2 is 128. That's my 8th term. Times 2 is 256. And then times 2 again is 512. So let's just make sure that I've got 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, I need one more. 512 times 2 is 1024. So we would say a sub 10 is 1024. Alright, now let's look at the second example. So we are going from -2 to then 4 to -8 to 16. So it looks very similar to the first problem, except I'm alternating from negative to positive to negative. So the only way that that's possible is if I multiply by a -2. So our answer is just going to be the same sequence as before. So we could go ahead and write 32, 64, 128, 256, 512, and 1024. And let's see if the 1024, which we know is my 10th term, let's just see if it's positive or negative. So when we multiply a negative times a -2, we get a positive. So we're just going to alternate signs. So we have the 16, which is positive. So the 32 is negative. So is the 128, and so is the 512. So the 1024 is positive. Alright, now let's look at the third example. How do I multiply to go from 40 to 20 to 10 and to 5? It looks like they're getting smaller. So we're actually going to halve this. So halving is the same thing by saying multiplying by by a half. So my common ratio is a half. Let's just find the next term. I know it says a sub 10, but it's just going to get really small. This number would just be 5 over 2. So we'll say a sub 5 is 5 over 2. And let's do the same thing for number 4. Let's find a sub 5. So how am I going from 30 to 15? This should be a -5, so change that as a typo. And see if you can figure that out. See if you can figure out what the common ratio is. How am I going from one term to the next? And then find me my 5th term. Alright, so we'll leave that one for homework. Now let's talk about the formula that we will use to find any term of a geometric sequence. The formula is a sub 1 equals a sub n times r to the n minus 1. A sub n is the nth term. A sub 1 is the first term. R is the common ratio. And n is the number of terms that we're speaking about. So let's find the 7th term of this sequence using this formula. So I want to find a sub 7. So we're going to say a sub 7 equals a sub 1, which we know the first term is 2, times the common ratio, then to the n minus 1 power. So if n is 7, then this here is 7 minus 1. And the common ratio is how we get from one term to the next. So 2 times what is 6? You should be thinking 3. And then 6 times 3 is 18. 18 times 3 is 54. So R is equal to 3. So a sub 7 is equal to 2 times 3 to the 6th power. Now all you have to do is type that into the calculator and you will get a sub 7. So I got 1,458. That would be my 7th term. Alright, I'd like you to try number 2 for homework. Same way, we want to find a sub 8. Alright, so a hint, you need to find the common ratio. Alright, let's jump to number 3. The question says, find the number of terms, which we'll call n, in this sequence. So remember, we're starting with the formula. Okay, so a sub n is also referred to as the last term. A sub 1 is the first term. So 3 times some ratio, and we're going to leave the n minus 1. And the a sub n is 729. So how do I get from 3 to 9 to 27? You should be telling me multiply by 3. So that tells me 3 is my common ratio. So the only way to solve for the exponent here is to try to find a common base. So we're going to divide by this 3 out here. And we have 729 divided by 3, which gives me 243 equals 3 to the n minus 1. Now I can log both sides if I want, or I could try to find a common base. Now, I know that I could rewrite 243 as 3 to the 5th power. So I have 3 to the 5th equals 3 to the n minus 1. Now that I have common bases, I can drop them and solve. So n is equal to 6. So it'll take me 6 terms to get up to 729. Alright, let's move on to the next page. Okay, sometimes questions will ask you to find a formula that you can use to find any term of the sequence. The following are all equivalent ways of asking this. Find the formula for the nth term, find the nth term, and find the explicit formula. Okay? So let's look at the first one together. We first need to find out what our common ratio is. So how am I going from 54 to 18 to 6? Well, some of you should be saying dividing by 3, but we're not allowed to divide, so we have to write it as a multiplication. So we can multiply by a third. That's the same thing as dividing by 3. So remember the explicit formula, a sub n equals a sub 1, r to the n minus 1. So if I want to find a formula for the nth term, just like we did with arithmetic, we leave all n's alone. So you're not plugging in any n's. So a sub n stays. A sub 1 is my first term, which is 54. My common ratio is 1/3, and we leave it to the n minus 1 power. And that's it. We can't multiply these because of PEMDAS, so we just leave our answer like this. This would be the formula that I could use to find any term of the sequence. Alright, I'll do one more with you. So in example number 2, how am I going from 3 to 12 to 48? Well, you should be telling me multiply by 4. So we're going to do the same formula, a sub n equals a sub 1, which is 3, my common ratio, which is 4, to the n minus 1 power. And again, that's it. We can't do anything more. So we're going to do example 3 and example 4 for homework. And now let's see what we could do with these last types of questions here. So question number 1 says, find the 6th term of a geometric sequence when the 4th term is -8 and the common ratio is 0.5. So we can map this out if we want by just drawing some lines. So we have the 4th term, 5th term, and 6th term. So my fourth term is negative 8, so a sub 4, and I want to find a sub 6. So technically with this one, all you really have to do is multiply by the common ratio. So common ratio is 0.5, so a half times negative 8 is negative 4, and then negative 4 times 0.5 again is a negative 2. So that is my sixth term. All right, number 2. Find the seventh term when the first term is 256 and the common ratio is 0.25. So we could actually count that out again. My first term, a sub 1, is 256, a sub 2, a sub 3, 4, 5, and 6. Okay, so we honestly just follow the pattern. So take a minute, multiply 256 by 0.25, put a number here, and then so on and so on. And tell me what a sub 6 is, and we'll leave that one for homework as well. So what I'd really like you to do now is talk about question 3 and 4. So find the common ratio for number 3, given that a sub 1 is 6 and a sub 4, 2, 3, 4, and a sub 4 is negative 3/4. So this is kind of like what we did with the arithmetic sequences. We have to understand what we're doing. We're multiplying 6 by some common ratio, and then we get this number. Then we multiply 6 again by that same common ratio, or whatever's here by this same common ratio, and we get this number. And then we multiply this number by the last common ratio to get the negative 3/4. So if we were to write an equation, it would be 6 times r times r times r gives me a negative 3/4. So 6 times r times r times r gives me this. So this is the same thing as saying 6r to the third equals negative 3/4. You could divide by 6. So in the calculator, negative 3/4 divided by 6. And that will give us negative 1/8. So r to the third is negative 1/8. And we take the cube root of both sides, and we get r is equal to negative 1/2. So they're asking for the common ratio, and there it is. So the same concept applies for question number 4. You're going to have to do the same procedure and then count back to find a sub 1. So you see how it says find the first term? So we want a sub 1. We have a sub 3, which is 18, a sub 4, a sub 5, 6, 7, and 8. Okay, so I've set up your problem. So I want you to do the same thing that I did up here for this problem and find my common ratio and then find A. All right, so I'm going to leave that one for you to do as well. All right, so let's see what you can do and come into class with questions tomorrow. Okay, have a good night.